We'll take a look here at the factored form of an equation. So we've seen standard form, we've seen vertex form, and this is factored form. And what you're going to end up doing here with factored form, it looks an awful lot like what we did last unit where we started to factor these quadratics down. Um, but we can use a factored form to help graph these by using the solutions. Remember, again, the solutions are what the x-intercepts were. And so if we're given something in factored form, the solutions are actually going to be the opposite p and then opposite q. Um, so you're going to take whatever values there and you're going to just switch the sign, and that's going to tell you where your solutions are. So your axis of symmetry is going to be halfway between the value of opposite p comma 0 and opposite q comma 0. That'll make sense in just a second. And so it's going to have an equation x equals. So that means, again, right, x equals, that means it's a vertical line. And then we can find the vertex, kind of like we did with standard form, by plugging in the x value from the axis of symmetry. So as we've seen over and over again, the graph will open up if a is positive, and it will open down if a is negative. So we look through here, just a quick look at all of this. We can look at all four examples at once in terms of opening up or down. That's a negative, so this is going to open down. All right. Maybe I'll just throw that off to the side so I have room to work. So this will open down. Here, there's no value in front, which means it's really just a positive 1. All right, that's just like a positive 1, so that's going to open up. Here it's a positive 3, so it's going to open up. It's a negative 1, so it's going to open down. Right? So the solutions, what you're going to do is you're going to look at the values that are sitting inside the parentheses, and you're just going to do the opposite. So you have negative 1, which means one of the solutions is x equals 1. And this is positive 3, which means the other solution is x equals negative 3. So you put a point on 1 and a point on negative 3. Now, the axis of symmetry. Well, it's going to go right through the middle of those 2 points. So really, you're just going to have to figure out what line goes right through the middle. And if you look, this particular line goes right in between it, right? It's 2 units to the left and 2 units to the right to get to those 2 points. So there's your axis of symmetry. Your axis of symmetry will go right through the middle of those 2 points. Now, what is that line? That's the line x equals negative 1. Right? So let's just practice those couple things with all of these points. Here we go. There's a positive 1, which means we have a solution at negative 1. Right? X equals negative 1. Let me clean that up a little bit. So one of our solutions is x equals negative 1. And then there's a positive 3, which means we also have x equals negative 3. So put a point at negative 1, put a point at negative 3, and then draw the line that goes right down the middle of those two. And that would be the line, if you count, that's the line x equals negative 2. Solutions, again, there's a positive 6, so we have a solution at x equals negative 6. Negative 2, which means we have a solution at x equals 2. So we're doing the opposite of each one. So plot your point 1, 2, 3, 6. There's negative 6. There's positive 2. And it's basically just a matter of counting in, right? So there's 1, 1, 1, 1. Just keep working your way in until you get to the middle. So there's the middle right there. So my axis of symmetry, missed the line there for a second. You go right through that point. And you could just count, just work your way from both ends until you count the same number of values. So that axis of symmetry is going to be at x equals negative 2. And we'll do one more here. So that would give us the solution x equals positive 2. This one gives us the solution x equals negative 2. And the axis of symmetry, well, let's put, there's our point at positive 2, there's our point at negative 2. Actually, our axis of symmetry is going to go right down the middle of those two, so it's on the axis, which is the line x equals 0. Now, to get that vertex, remember, to get the vertex, what we're going to do is we're going to plug in the value from the axis of symmetry. This is a great opportunity to use your calculator, and you're just going to be careful with parentheses. So the value we're going to plug in is the axis of symmetry value, all right? That vertex is going to go somewhere on that dotted line. So let's plug in the value associated with that dotted line. So negative 2 Right, so here's the equation of the line, right? So what we're going to do, guys, is we're going to come back, and wherever there's an x, we're going to plug in our value from the axis of symmetry. So that would be -1, -1. And we can let the calculator take over if you'd like. Just plug it into the calculator, put parentheses in there, and make sure that we put everything in the right place at the right time. So we got -2, parentheses, -1 minus 1, opening parentheses again, -1 plus 3. And that gives me the value 8. So the vertex go up to point 8. 1, 2, 4, 5, 6, 7. We're just a little bit off that graph. Let me get rid of that arrow so it's not confusing. And then we already said, hey, this thing should open down. And sure enough, when I put that point on here, if I connect those points, this thing does in fact open down. So go back and put the vertex as a point, and that was the point, right? -1, comma 8. Here for part 10, right? We got to plug in, we got x plus 1, x plus 3. There's our function. And we're going to plug in this value right here, x equals -2. So go back. We're going to replace the x's with that value. So -2 plus 1. Some of these you could probably do by hand. That's -1. -2 plus 3 is +1. So that equals -1. So go to your line of symmetry, put a point on -1, and then connect the dots. Go back, write the coordinates of that vertex, and that'd be the point -2, -1. Okay, a couple more examples. So we have 3, x plus 6, x minus 2 in parentheses. And we're going to plug in the value x equals -2. So go back, get rid of your x's. We're going to plug in x equals -2, x equals -2. Again, you could type that into the calculator just like you see there, and it'll take care of the rest for you. Or you could do it by hand. So we have 3, -2 plus 6, -4. -2 minus 2 is another -4. So we end up with 3 times -4 times -4 is 16, which is 48. So the issue here is way off the screen. So we'll just kind of put a point way up here off. Oh, excuse me. One of those is positive. That's throwing me off. That should have been 3 times +4 times -4, which would be 3 times -16, which is -48. All right, so way off to the bottom, excuse me. And that's what caught me there. I realized I should have been opening up. I wrote that down at the very beginning. That kind of helped me catch my error. So we'll connect those. And that vertex, right, it's got to be on the line of symmetry so we know it's at -2, and then you go down to 48. Apologize for that not being right there on the graph easily for you guys to use. And so finally, number 12, I'm just plugging in, right? We got x minus 2, x plus 2. And so what we're being asked to do, what do we plug in for x? We plug in the value from the axis of symmetry, which is 0. So plug in 0. So we have a negative. 0 minus 2 is -2. 0 plus 2 is 2. So we have a negative, and then there's a -4, which ends up being a +4. So go up 1, 2, 3, 4. This should be opening down. So this is good. Everything looks solid. And now just give me the coordinates of that vertex. That would be the point 0, 4, and put it on the line. So this is the form known as factored form, not used very often. Standard form is probably the most often. Vertex form would be the next most used form, but then we'll see factored form here and there throughout the course.